We first cd into the directory. We then just run the bash script, and it should start up the application. We then can select an audio file. Then we can listen to that audio file, change the speed, do whatever. And then when we finally want to decode and try to predict the text for it, we click the decode button, and we can assign a person if we have decoded previous messages from this person, or we can add a new person. We can specify input-output text, basically labels if we have them, and we create the decoder. Once completed, we can visualize the decoder. There's all the metadata. We can add additional metadata items if we wanted. For example, here we can just label this dataset as a testing dataset. And then when you close it, it will rebuild the view. And so the first thing you want to do is kind of just visualize these signals. And so we can just visualize the raw signal and create a video of it with a certain frame rate. Once finished, we can then visualize the audio within our application. And then we can also make different video types using the create video button. We can remove the ones we don't want to make. These are all FFmpeg videos. We can then visualize the videos. Here we see the frequency. The next step is then to transform the audio to Fourier. And here we then can go back and visualize the Fourier transformation. And here we just look at the first 13 seconds. The resulting signal then appears in our video module. We can look at the clicks. We now see that everything is now based at 0. We can threshold it. So next we click the threshold keystrokes button. We set the start time, end time, minimum and maximum threshold, minimum distance between keystrokes, length between keystrokes, and then the proportion. Now upon completion, we can visualize the peaks that are detected. We can zoom in on specific locations, and we can see what's above the threshold, see what the clicks look like, see what the sound makes when the click comes up. And the next thing we do is we cluster the keystrokes. We can choose how many features we want to keep, like what hertz we want to keep the signal between. Then we can set the number of clusters we have for k-means, a couple other parameters. Upon completion, you can then start to predict text. This is still pretty early stages, but here you basically set the transition smoothing parameter, which is when the value is higher, it means the transition between characters is more uniform, and when it's lower, it's more equal to the text that we're training to get the bigrams on. Then here we can see the text it creates, and then the actual text. Here it's around 30 to 40% character accuracy, and you can see that it's getting pretty good on spaces, but some of the other characters are just not as great.